Welcome to Edupedia World. In this video, we will discuss about the calculations of arithmetic mean. Types of arithmetic mean. Arithmetic mean is computed in two ways, or there are two types of arithmetic mean. Simple arithmetic mean and weighted arithmetic mean. In simple arithmetic mean, all the observations or items in a series are given equal importance. In weighted arithmetic mean, weights are assigned to various items according to their importance. So we will discuss both the means one by one in our coming slides. Simple arithmetic mean. Simple arithmetic mean can be calculated in the following three series. First, individual series. Second, discrete series. Third, continuous series. Individual series is calculated with the help of ungrouped data, and discrete and continuous series is calculated with the grouped data. Also, there are three methods used to calculate arithmetic mean. First, direct method. Second, shortcut method, which is also called assumed mean method. And the last one is step deviation method. All these methods will be discussed in details. Let us study the calculation of arithmetic mean in three series by three methods each. So let's start with individual series, ungrouped data. In these series, there are no frequencies. Items or values of the variables are listed singly. For example, marks obtained by 10 students listed singly. Second, in other words, there is no class of the items and also no frequency. Third point, there are three methods to calculate means, that is direct method, shortcut method and step deviation method. First, we will start with direct method. Arithmetic mean under direct method is the sum of all observation in a series divided by the total number of observations. The quotient so obtained is arithmetic mean. Symbolically, it will be represented by the letter x with a dash above it equals to sigma x divided by n. Let us understand with the help of a following illustration. Daily wages of 10 workers in a factory are given. We have to find out the arithmetic mean by direct method. First, we will arrange the wages in ascending order, that is, we will start with 140, then 150, 180, 200 and so on. After that, we will obtain sigma x by adding all the values of variable x. After that, we will divide the total values by the number of observation to get arithmetic mean. We will apply the formula. We have got the sigma x, that is 2500. Number of observation is 10. So we will divide 2500 divided by 10. So we will get the mean, that is rupees 250. The average daily wages of workers are rupees 250. This is how we will calculate mean with the help of direct method. Shortcut method or assumed mean method. If the number of observations in the data is large, it is difficult to compute arithmetic mean by direct method. We use assumed mean or shortcut method to make calculations easier. In this method, we can assume any particular figure in the data as arithmetic mean, and deviations from this assumed mean are calculated. Symbolically, it will be represented as with letter x with a dash above it equals to a, which is assumed mean, added by sigma d, d means deviation, divided by n, which is number of observations. Let us discuss it with the help of a following illustration. We have to calculate arithmetic mean of the daily wages of 10 workers by shortcut method. First, we will arrange wages in ascending order, that is 140, 150, 180, so on till 450. Then we will select assumed mean, that is 220 in this particular illustration. After that, we will calculate deviation in the third column. For that, we will deduct assumed means from the variable. We will got the deviation. Then we will derive the total of the deviations, that is sigma d, and we got sigma d is 300. Then we will apply the formula of shortcut method, that is mean equals to a means assumed means plus sigma d divided by n. Here assume means is 220 plus sigma d is 300, which is divided by n, which is 10. After calculating it, we will get 250 as arithmetic mean. This is how we will calculate arithmetic mean with the help of shortcut method. Next, we come to step deviation method. This method simplifies the shortcut method. The calculation can be further simplified by dividing all the deviations taken from the assumed means by a common factor, which is c. Symbolically, it will be represented as letter x with a dash above it equals to a plus sigma d dash by n multiplied by c. Let us understand with the help of a following illustration. We have to calculate the arithmetic mean of the daily wages of 10 workers by step deviation method. We will make a table of 4 columns. In the first column, we will write the number of observation. In this particular illustration, we are having 10 number of observation. In the second column, we will write daily wages, which will be denoted by letter X. We will arrange wages in ascending order that we have done in the previous methods also. We will start with 140, 150, 180 and so on till 450. We have select assume means here is 220. After that, we will calculate the deviations from assumed means as we have done in the earlier methods also to get the sigma d. After that, we will divide each deviation by common factor, that is c, to get the d dash. At the end of it, we will get the sigma d dash, which is 30. Then we will use the formula of step deviation method to calculate the mean. The formula is x with a dash above it, which is mean, equals to a assumed means plus sigma d dash divided by n, which is number of observation, multiplied by c, which is a common factor. In the place of a, we will write 220 plus sigma d dash, we got 30 divided by 10, that is number of observation, and in the place of c, we will write 10 as a common factor. After calculating it, we will get 250 as a daily average wage of a worker. This is how we will calculate mean with the help of step deviation method. Next, we come to discrete series, grouped data. In these series, there are frequencies corresponding to different values of the variables. Values of the variables are arranged in groups which are exactly measurable. There are 3 methods to calculate arithmetic mean. They are direct method, shortcut method and step deviation method. Each method will be discussed in details in the coming slides. Direct method. In this method, frequency against each observation is multiplied by the value of the observations. The values so obtained are summed up and divided by the total number of frequencies. Symbolically, it will be written as with the letter x with the dash above it, which means arithmetic mean of the series equals to sigma f x divided by sigma f, where f is frequency of the variable and x is the variables. Let us understand this with the help of a following illustration. In the following table, which is given, the marks obtained by 100 students in a class. We have to calculate the arithmetic mean by direct method. First, we will make the table of 3 columns. In the first column, we will write marks, which is denoted by x. In the second column, we will write number of students, which is denoted by f. And in the third column, we will write the product of fx. We will multiply the frequency with the variable and get the product fx. That is 10 multiplied by 15, which comes 150. 20 multiplied by 10, which comes 200 and so on. Then we will calculate the sum of product, that is sigma fx, which comes 3100. After that, we will divide sigma fx by total number of observations, that is sigma f or n, which is 100 in this particular illustration. Then we will write the formula of direct method, that is arithmetic mean of the series equals to sigma fx divided by n or sigma fx divided by sigma f. We will put on the values which we have calculated in the table, that is sigma fx is 3100 and sigma f is 100. After dividing it, we will get 31. So, average marks of students is equals to 31. This is how we will calculate arithmetic mean of discrete series in the direct method. Next we come to shortcut method. We can use this method to calculate arithmetic mean in order to simplify arithmetic calculations. Deviations taken from assumed mean are multiplied with frequency to get FD. Symbolically it is written as letter X with a dash above it equals to A plus sigma FD divided by sigma F, where X with a dash above it is arithmetic mean of the series, A is assumed means, F is the frequency, and D is the deviation. Let us understand this with the help of a following illustration. In this, we have to calculate the average marks of students from the data given with the help of a shortcut method. First, we will prepare a table with a 4 column. In the first column, we will write marks, which is denoted by X. In the second column, we will write number of students, which is denoted by F. In the third column, we will write deviation, which we will get by deducting assumed means from the variable, that is X. And in the fourth column, we will write the product of frequency and deviation, that is FD. First, we will select the assumed means. It is 30 in this particular illustration. After that, we will calculate the deviations from the assumed means, that is X minus A equals to D, which is in the third column. After that, we will multiply deviations by frequency and get FD, which is in the fourth column. We will add the product of deviation and frequency and find sigma FD, which is 100. After getting sigma FD and sigma F from the table, we will use the formula of shortcut method, that is arithmetic mean of the series equals to A plus sigma FD divided by sigma F. In the place of A, we will write 30, that is assumed means. Sigma FD we got 100 and sigma F is 100. After putting of the values, we will get 31 as a result, which is the average marks of the students. This is how we will calculate arithmetic mean by using shortcut method. Next we come to step deviation method. We can further simplify arithmetic calculations done by the shortcut method. All deviations taken from assumed mean are divided by common factor. Symbolically, it can be represented as X with a dash above it equals to A plus sigma FD dash divided by sigma F multiplied by C, where A is assumed mean, F is frequency, D dash is equal to X minus A divided by C, and C is the common factor here. We can understand this with the help of a following illustration. We have to calculate the average marks of students given in the table with the help of step deviation method. We will prepare 5-column table. In the first column, we will write marks, which is denoted by X. In that column only, we will take 30 as assumed mean. In the second column, we will write number of students, that is frequency, denoted by F, that is 15, 10, 40 and so on. In the third column, we will write deviation, which we will get by deducting assumed mean from the marks, which is X. In the fourth column, we will divide deviation by common factor, which is 10. D divided by C, we will get D dash. In the fifth column, we will multiply step deviation by frequency. We will get FD dash. And we will add the product of step deviation and frequency and we will get sigma FD dash. After getting sigma F and sigma FD dash, we will use the formula of step deviation method, which is assumed mean plus sigma FD dash divided by sigma F multiplied by C, where A equals to assumed means. Sigma FD dash is the sum of the product of the step deviations and their respective frequencies. C is the common factor and sigma F is the number of students, that is frequency. After putting on the values, we will get 31 as the average marks of the students. This is how we will calculate average mean with the help of step deviation method. Note: We always get the same answer by direct, shortcut, and step deviation methods. The step deviation method reduces the amount of arithmetic calculations. Continuous series, group data. In these series, values of the variables are arranged in groups which are not exactly measurable. In these series, values of the variables are shown in the continuous manner. There are frequencies corresponding to different values of the variables. For example, 10 to 20 marks, number of students is 4. 20 to 30 marks, number of students is 6. 30 to 40 marks, number of students is 9, and so on. In continuous series, the method of calculation of arithmetic mean is the same as in the case of discrete series. The only difference is that in continuous series, midpoints of various class intervals are required to calculate the average or arithmetic mean. There are three methods: direct method, shortcut method, and step deviation method to calculate the arithmetic mean. Direct method. This method is exactly the same as discussed in case of discrete series. The only difference is that we need to first convert continuous series into discrete series by taking mid values of each class. Symbolically, it can be represented as arithmetic mean of the series equals to sigma fm divided by sigma f, where f is the frequency and m is the midpoint. We can understand this with the help of a following illustration. We have to find out the mean of the following distribution by direct method. We will make a table of 4 columns. In the first column, we will write marks, which is denoted by X, which are 0 to 4, 4 to 8, 8 to 12, and so on. In the second column, we will write number of students, which is denoted by F, 4, 8, 2, and so on. After adding it, we will get sigma F, which is 20. In the third column, we will write midpoints that we will get by applying the formula, that is L1 plus L2 divided by 2, where L1 is the lower limit of the class interval and L2 is the upper limit of the class interval. After getting the midpoints, in the fourth column, we will write Fm. Fm is the product of frequency and the mid value. After that, we will calculate the sum of products of mid values and frequency and find sigma fm, which is 180. We will divide sigma fm by total number of observations, that is sigma f, which means 180 divided by 20, we will get 9. So for this particular illustration, the mean marks is 9. Next we come to shortcut method. Calculation of arithmetic mean by shortcut method is same as in case of discrete series. In continuous series, mid values of the class intervals are calculated. Deviations taken from assumed mean are multiplied with frequency to get FD. Symbolically, it can be written as arithmetic mean of the series equals to A plus sigma FD divided by sigma F, where A is the assumed mean, F is the frequency, and D is the deviation. We will understand this with the help of a following illustration. We have to calculate the arithmetic mean by shortcut method of the table given. We will make a table of 5 columns. In the first column, we will write marks, which is denoted by X. In the second column, we will write number of students, which is denoted by F, which is the frequency. We will add up the frequency to get the sigma F, which is 20 in this particular illustration. In the third column, we will write the midpoints that we get by applying the formula of L1 plus L2 divided by 2, where L1 is the lower limit of the class interval and L2 is the upper limit of the class interval. After getting the midpoints, we will take 10 as assumed mean for the following illustration. Then we will calculate the deviations from assumed means, that is M minus A equals to D. After calculating the deviation, we will add the products of deviation and frequency and get sigma FD. In this particular illustration, sigma FD is equals to minus 20. After that, we will apply the formula of shortcut methods, that is A plus sigma FD divided by sigma F. We will put up the values that we got from the table and we will get the mean marks, which are 9. This is how we will calculate the mean marks with the help of shortcut method. Step deviation method. We can further simplify arithmetic calculations done by the shortcut method. All deviations taken from assumed mean are divided by the common factor. Symbolically, it can be represented as arithmetic mean equals to A plus sigma FD dash divided by sigma F multiplied by C, where A is the assumed mean, F is the frequency, D dash is the deviation, and C is the common factor. Let us understand this with the help of a following illustration in which we have to calculate the arithmetic mean of the marks from the following table. We will make table of 6 columns. In the first column we will write marks, which is denoted by X. In the second column we will write number of students denoted by F, which is frequency. After adding up the frequency we will get sigma F, which is 20. In the third column we will write the midpoints that we will get by applying the formula of L1 plus L2 divided by 2. After getting the midpoints from the class intervals, we will take 10 as assumed means. In the fourth column, we will calculate the deviation, which we will get by deducting assumed means from the midpoints. After calculating the deviation in the fifth column, we will divide deviations by common factor, that is D divided by C, and we will get D dash. We have taken C equals to 4 as a common factor. After that, we will multiply step deviations by frequency and get the product FD dash. We will add the products of step deviation and frequency and get sigma FD dash, which is minus 5. After getting sigma F and sigma FD dash, we will use the formula of step deviation method, that is arithmetic mean of the series equals to A plus sigma FD dash divided by sigma F multiplied by C. We will put up the values that we got from the table. After applying the values, we will get 9 as the mean marks. Thank you for watching Edupedia World videos.